Good afternoon, everyone. This is Shagun Mishra. In this video, I will tell you about the finite state machine or finite automata. It is of two types, that is finite automata with output, and second is finite automata without output. So, I will tell you briefly about the finite state auto machine without output and their parts. It is here described in three parts, that is DFA, NFA, and epsilon NFA. But mainly it is of two types, that is DFA and NFA, that is told in this video. So let's start. Finite state automation or automata. Finite state automation can be represented by five tuples that are Q, sigma, delta, Q naught, F. Here Q is a finite non-empty set of states. Sigma is the non-empty set of input called input alphabet. Here delta is a transition function that tells the mapping of Q into sigma. Here Q naught is the start state, and F belongs to the Q, that is the final state. Okay, so for knowing about the finite state automata, we know that it is described by the transition diagram. A transition diagram is a finite direct labeled graph in which each vertex represent a state and the edges are labeled as input and output. Okay, so here this is the diagram that shows the finite state automation. Here this is the initial state, it is the final state that is represented by double circle. Here it is told that at the input 0 the value is Q naught itself, and at the input 1 the value is Q1, because this arrow is passing from the Q naught to Q1 as represented in this table. For Q1 the input value at 0 is Q naught, and at 1 it is Q1 itself. Now we will discuss about the types of finite state automata. First is deterministic finite state automata, and second is non-deterministic. So the finite automata is called deterministic finite automata if the machine is read as an input string one symbol at a time. Means, suppose these are the states Q0, Q1, Q2. Here we are seeing that at the 0 input the value is Q0 itself, and at 1 the value is Q1, nothing else for Q0. Means for here it is written that the machine which is read as an input string for one symbol only, means at a time, means at one time one symbol will represent only one value, that is in the deterministic finite state automata, or we can say DFA. And at Q1 for at 0 the input value is Q2, and at 1 the input value is Q1 itself. Similarly for Q2 we see that at 0 the input value is Q2 itself, it is the final state, that's why the double circle is there. And for 1 there is no value, that's okay. For non-deterministic finite state automata, the finite state automata is called non-deterministic finite automata if for any particular input symbol the machine can move to a combination of the states. Means for a single value there can be more than one representation. Like here for 1, the value, the input value is q1. For q0, the input value at 1 is q1, and also q0 itself as represented. For q1, here we see the input value at 1 is q2. Okay, and for q2, the input value at 0 is q2 itself, and at 1 the value is q2 itself and also q4 as represented. For q3, it is 0, at 0 it is q4, and yes, for here I think it will be 1. Okay, and for q4, the value at input 0 is q4 itself, and at 1 is q4 itself. So here it is the note that every DFA is NDFA, means every deterministic finite state automata is non-deterministic finite state automata, but converse need not to be true. बट इसका उल्टा हो, ये ट्रू नहीं है, ये ट्रू ज़रूर होना ज़रूरी नहीं है. Then is converting NDFA to DFA, which is the important topic. Here the NDFA diagram will be given and we need to convert it into DFA. So for this, here it is given, which represents the NDFA. For Q0 state, it is the initial state. For Q0 state, the value at input 0 is Q1, and at 1 the input is Q1. So the diagram shows for DFA the this table is represented in this way. Okay, but for NDFA it will be represented as follows. Okay, so here we see that at Q0, when at 0 the input value will be Q0 itself, and here we see, and at 1 this arrow is towards the Q1. So at 1 the input value for Q0 is Q1. Okay, for Q1 state, the input value at 0 is Q1. Okay, also for input value at 0 it is Q2 also, means Q1 and Q2 both are there. So this type of table shows the NDFA automation, and the table which represent the single values, that shows the finite state automata, FSA. So at 1, okay, Q1 at 0 is Q1 comma Q2, and at 1 is Q1 itself. Here now for Q2 we will see that the input value at 0 here is Q2 itself, but for 1 it is Q2 and Q1 also, means Q1 comma Q2. Okay, now for converting this table into DFA table, this is the table for non-deterministic, and now for converting it into DFA it is as follows: state, input, that is 0, 1. Here states are Q0, Q1. Sorry, firstly Q0. Here our table for NDFA was this. So First line we will write it as it is, like q0 and q1. But here now we will write next state, that will be q1. At q1, the value in this table is q1 comma q2 and q1. Okay, that is q1 comma q2, and here is q1. Now what difference in this table? Okay, so here the next state will not be q2, it will be q1 comma q2. Okay, so for q1 comma q2, the input value at 0 will be, look, for q1 comma q2, here we see that at q1 the values are q1 and q2, at q2 the values are q2, is q2 only. So the overall value will be q1 comma q2 itself. Okay, and the value for q1 comma q2 at 1, it will be q1 q1 q2, like q1 comma q2. Okay, so here will be q1 comma q2, here also it will be q1 comma q2. Okay, so this is our final state, this our final state. Now diagram for this table will be, three states will be there, that is q0, q1 and q1 comma q2, this one. So at q0, for the input value at 0, this will be represented as this only, at 0. At 1 it is q1. Okay, q1, for q1 state the value is, at 0 is q1 comma q2, the value at 0 is q1 comma q2, and value at 1 is q1 itself, it will be represented as it is. And for q1 comma q2, the input value at 0 is q1 comma q2 itself, and for 1, that is q1 comma q2. And it is, since it is the final state, so this will be represented as the double circle. Okay, so this is the diagram for the DFA, means deterministic finite automata, and we have converted this NDFA diagram into DFA diagram, and from this transition table to the deterministic finite state automata or DFA table, this is like this. Okay, so next we will study that, suppose this is the diagram given for NDFA. Okay, and the table for this NDFA is this. Here at the state S0, the value for input at A will be S0 itself, here it is represented, and also this is S1. Look, at B, so where B is gone, for from S0 the B is for B the input value is S3. Okay, and for S1 state at A the value is S0, and for B the value is S3, also S1 itself. Look, so at S2, now S2 is this, and S3, this is the final state. At S2, at A there is no value, okay, and for B this is S0 and S2 S2 itself for B. Now for S3, at A the value is S1, and also S naught means S naught S1, and at A it is also S2. This is represented. Okay. And for B the value is, for B the value is, okay, yes, S1. S1, this is the value. Now for converting this NDFA into DFA, what we will do, we will make a table like this. Input, okay, here will be state, state A and B. Okay, so first of all we will write the first row as it is, that is S0, S0 comma S1 and S3. Okay, now next it will be S0, then it will be S0 comma S1, means the next value is S0 comma S1 after S0. So we will write here S0 comma S1. Okay, for S0 comma S1 the value at A will be S0 S1 S0, means S0 comma S1. Okay, at B it will be S3 S1 S3, means overall it will be S1 comma S3. Okay, now what it will be, next value for the state will be S3, because S0 is written here. Next value S0 comma S1, that is also written. Next to it is S3. So for S3 the value is this S0 comma S1 comma S2 and S1. Okay, now after S3 the value is S0 comma S1, that is as it is written. Then it is S0 comma S1, it is written. Then it is S1 comma S3. So here the state will be S1 comma S3. So for S1 comma S3 the value at A will be S0 S0 S1 S2, means S0 S1 S2. S0 S1 S2 is the input value at A. Getting. Next for B the value will be, for S0 and S3 the value will be S1 S3 S1, means S1 and S3 itself. Now the next value is S3. This is written as it is. Next to S3 it is S0 S1 S2. So the state will be, so our state will be S0 S1 S2. Okay, so for S0 S1 S2 the value for input value for A will be S0 S1 S0, means S0 comma S1 itself. Now value for input value for B will be for S1 S1 S2 S0 S1 S2, that is S3 S1 S3 S0 S2. Okay, so it will be S0 S1 S2 and S3. S2 and S3, and next value that is S1, means S3 is written as it is, S1 comma S3 is written. Okay, now it will be S3 S1 S1, because the value after S0 S1 S2 is S1 itself. So for S1 the value will be this, from this table S0 S1 comma S3. The value after S1 is S1 S3, then is S0 S1 S2, that is represented here. Then is S1 comma S3, that is also represented. Then it is S0 S1 S2. Then it is S0 comma S1, that is also represented. Then it is S0 S1 S2 S3. S0 S1 S2 S3, it is remaining. So for S0 S1 S2 S3 means for all these states the value at A will be S0 S1 S0 S0 S1 S2, means S0 S1 and S2. And for B the value will be S3 S1 S0 all values are there. So means the value for the input value at B will be S0, S1, S2 and S3. Okay, so this is the uh, table for DFA when we converted this into this. Okay, now we will draw the diagram that is as this. Here we will make these states which are represented here, that is S0, S0 comma S1, S3, S1 comma S3. All these states are made here. Okay, then we will represent it as we have represented earlier, like we will represent the input values S1 comma S0 comma S1 and S3 as follows. Okay, thank you.